The video is on factoring patterns. You will need to pause the video several times as you watch. First thing we're going to discuss are factoring patterns. There are two factoring patterns, the difference of two squares and perfect square trinomials. So here's a place where you should pause. The difference of two squares looks like a squared minus b squared, and perfect square trinomials look like a squared plus 2ab plus b squared. Difference of two squares, you'll notice, is missing the middle and factors as a plus b times a minus b. And perfect square trinomials factor as a plus b quantity squared. You can also have a perfect square trinomial where in the middle term, instead of being positive, the middle term is negative, and it factors as a minus b quantity squared. So again, you should pause and take notes on that. Let's look at an example. X squared minus 16. X squared is a square. 16 is a square. Negative 16 is negative 4 times 4. X squared is x times x. So this factors as x plus 4 times the quantity x minus 4. A perfect square trinomial, something like x squared minus 6x plus 9. 9 is 3 times 3. X squared is x times x. Notice that when you multiply 3x, when you multiply x times 3, you get 3x. When you multiply x times 3, you get 3x. When you add those, you get 6x. So I believe that negative 3 times negative 3 is also 9. So this is called a perfect square trinomial, and it factors as x minus 3 squared. There can be a coefficient, so you could have some, instead of x squared minus 16, you could have something like 9x squared minus 25. 9x squared is 3x times 3x. Negative 25 is negative 5 times 5. So this factors as 3x plus 5, 3x minus 5. And of course, the order does not matter. You could have a coefficient for perfect square trinomials as well. So let's say I gave you 4x squared plus 20x plus 25. The hint to you should be when you see the 4 and the 25, or when you see 9 and 25, or 16. Whenever you see a perfect square, 1 doesn't really count in this particular case. 4, 9, 16, 25, 36, 49, 64. That's 8. 9 squared is 81, 100. On down the line. Those are perfect squares. When you see that in a factoring problem, that should be a clue that, it might be special. So 4x squared is 2x times 2x. 25 is 5 times 5. Notice that in the pattern, it says 2 times a times b. Well, 2x times 5 is 10x. And there's 2 of them, which would give you 20x. So this factors as 2x plus 5 quantity squared. So what I want to look at right now is a little bit more complex perfect square trinomials. So let's say you didn't recognize that it was a perfect square trinomial. Okay, let's say you didn't recognize it. So let's say you have x squared. How about, let's stick with x squared minus 6x plus 9. Let's just go back to that example. And again, you should be pausing and taking notes as we go. It'll make future lessons much easier. So you would do the diamond, and you would say 9 goes on top, and negative 6 goes on the bottom. And what works would be negative 3 and negative 3. And so you would, that's not true. Yes, it is. Sorry, I had to take a second look. Okay, A is 1, so you can shortcut it. Minus 3, minus 3. This is not, just so you know, this is not simplified. And if you leave your answer as x minus 3 times x minus 3, I will not give you full credit. The proper way to write this is x minus 3 squared. So I will say that again. If you leave your answer as x minus 3 times x minus 3, you will not get full credit. The proper simplified answer is x minus 3 squared. Okay, well, let's say you didn't recognize that it was a shortcut, and I promise you this is going somewhere. So same problem again. So you missed the pattern, and you missed that A is 1. So there's a method to my madness, just trust me. Or fast forward me. But I recommend that you don't. Okay. So those of you who don't use the box, I am gonna kind of encourage you to do so just for this type of problem because it leads to a pattern. So I have x squared, and instead of negative 6x, I'm going to put negative 3x, and 9. First box, first term, last box, last term, and then the negative 3. And so you would look and you would say, okay, x and x, which is nice, that's how it usually goes, minus 3, and you would get the same answer. So there's a process which you may or may not have learned already called completing the square. And this is where the square comes from. So we call it the box, but really it's a square. I don't know why they call it a box. So where am I going with this? Okay, I'm going to give you a partial trinomial. I'm going to give you a partial trinomial. Perfect square trinomial. So you have a squared minus 2ab or plus 2ab plus b squared. And I'm only going to give you a piece of it. So let's say I give you x squared plus 8x. So, excuse me. I want to put a number there that's going to make this trinomial a perfect square trinomial. I want to create a number here so that it makes my trinomial perfect. So this is what I mean, and this is why I had you do the box in the previous problem. Square. So I have x squared. And I need to know, essentially I need to fill in all three of these boxes. So here's how we're going to do that. You see how in the pattern, it's 2ab, whether it's positive or negative doesn't matter, it's still 2ab. So I'm going to cut the 8x in 2. So I'm going to take the 8x and I'm going to split it in half. That's going to be 4x and 4x. Half of 8x is 4x. So now the big question is, what should go here to make this so that it factors nicely as maybe x minus 3 quantities squared or 2x plus 5 quantities squared? Well, if you take out the GCF between x squared and 4x, you get x and x. And the GCF here is sorry. So a number times x is 4x. Some number times x is 4x, and that's 4. And some number times x, so x times something here has to be 4x, and that's 4. What number needs to go here? 4 times 4, which is 16. That is called completing the square. So this big question mark would be x squared plus 8x plus 16. And it would factor perfectly as x plus 4 quantity squared. Okay, so again, pause the video as you go so you can take a look at what's happening. Let's do another one. Let's look at x squared minus 12x. And I want to know what should go here. Okay, so let's make our box. You don't have to make the box, okay? I'm doing that because I think it helps you visually. Okay, so first box, first term. Great. To get these two boxes right here, I'm going to split it in half, which would be negative 6x and negative 6x. I'm working backwards. So here it says 2ab, negative 2ab. So if I'm working backwards to factor, instead of multiplying by 2, I should divide by 2. Instead of multiplying by 2, I'm going to divide by 2 because I'm going backwards. So negative 12x becomes negative 6x and negative 6x. X and x. Negative 6, negative 6. So what should go here? Hopefully you said 36. I have now created a perfect square trinomial, and it factors as x minus 6 squared. Let's do one more, and let's look at the problem that we did earlier. That was 4x squared plus 20x plus 25. Okay, so I'm sorry, I changed my mind. Let's do something different. Sorry about that. Let's do 4x squared plus 36x minus plus 81. Plus, keep changing my mind. No, not plus 81. Forget the 81 is there. Well, now you know the answer. Now you know the answer. Oops, that's okay. We'll still do the practice. I want to know what number, 81, should I add to make this a perfect square trinomial? Okay, so cut the 36 in half. Cut the 36 in half. So you get 4x squared. And then half of 36 is 18. And 18. Okay, so 4x squared, we're going to do 2x and 2x. And the reason why I'm doing 2x and 2x as opposed to 1x and 4x is because I want to do a perfect square. So the square root of 4 is 2. This is now going to become 9 and 9. 2x times 9 is 18x. 9 times 2x is 18x. And remember, you split the 36 in half. We've got two boxes, split it in half. So 9 times 9 is indeed 81, which we kind of knew before, but that's okay. So this factors as 2x plus 9 quantity squared. Okay, very, very last thing. So that's our last example. I just want to do a notation. You remember from graphing parabolas, or from the quadratic formula. If you remember from graphing parabolas or the quadratic formula, this is called standard form. Everything has a standard form. Standard form of a line, standard form of a quadratic, standard form of an ellipse. So you will hear in directions to find C. That's what the directions will say. The directions will say, find a value of C. And the C that they're referring to is right here, the constant, which is exactly what we've been doing. I just wanted you to be aware of the notation. So I'll say find a value of C to complete the square. I believe that's what the directions will say, something like that. But when you see C, when you see the variable C, that's what they're talking about. So in the previous example, that was 81, okay? Homework will be attached to the video.